This is Physics 30, Chapter 4, Lesson 5. In this lesson, we're going to talk about Hooke's law as well as springs. Hooke's law is this little equation, F equals kx. F we know is a force, but we don't really know what k and x are right now. Hooke's law talks about the amount of compression or extension of a spring is being proportional to the force applied to it. So in the equation, F stands for force, measured in newtons. K stands for the spring constant, which is measured in newtons per meter. So you can think of that as kind of like your coefficient of friction. It's a standard number for the spring that you sometimes may be given and sometimes need to calculate. And X is the distance that the spring is either compressed or stretched. Energy in a spring can be defined by the equation E equals 1/2 kx squared. You'll notice this energy in a spring formula or equation looks very similar to the kinetic energy equation. We also have the equation T equals 2 pi of the square multiplied by the square root m over k. In both of these equations, k is the spring constant, again measured in newtons per meter. X is the distance that the spring is either compressed or extended, and t is the period measured in seconds. So an example, how far will a 10-kilogram mass stretch a spring with a constant of 120 Newton meters? Using our equation F equals kx, we know that the force will be equal to mass times acceleration, so we can replace F with ma. The mass is 10 kilograms, and acceleration would be due to gravity, so 10 times 9.8 will be equal to the constant of 120 multiplied by the distance x. Multiplying this together and then dividing by 120, we get that x is going to be 0.82 meters. A second example, how much energy is stored in a spring with constant 80 newtons per meter when you stretch it 2 meters? This one we're talking about energy stored in a spring, so we can use the equation E equals 1/2 kx squared. Plugging in what we know that the constant is 80, and we know that the distance stretched is 2. Multiplying that all together, we get that the energy stored will be equal to 160 joules. A third example. What is the period of oscillation when you hang a 5-kilogram mass on a spring with a constant of 10 newtons per meter? So if you have this spring and you suddenly attach a weight to it and then let go, the weight is going to stretch the spring, but then it's going to bounce back a little bit and it's going to oscillate for a while. So we want to know what that period is, how long that actually takes between bounces or oscillations. So we have the equation T equals 2 pi square root m over k. We can plug in everything that we know, which is just m and k. We know that the mass is 5, and we know that the spring constant is 10. Multiplying it all together, we get that t will be equal to 4.4 seconds. For example questions and practice, we're going to look at page 200, numbers 1 to 4, and also 6 to 8.